Alright, so let me explain it in simpler terms. So let's try solving number one. Johnny runs 3 kilometers 40 degrees, blah blah blah. You just need to look at the numbers. So that's why we have to find the given first. 3 kilometers 40 degrees north of east. Uh, this is irrelevant, so we don't need that. And then 4 kilometers 20 degrees west of north. Alright, so now we're gonna have to uh, graph it or um, visualize it first so that it's easier to explain. So let's start with the first given. This is the first vector, vector A, and then this is the second vector, which is vector B, right? So the first vector, let's draw a uh, Cartesian plane. So 3 kilometers north of east. So north of east is basically the north side of east. So we start with east and then go to the north. So in the Cartesian plane, obviously, we're going east here, and then we're gonna go north above. So kind of like this. And then we draw the first vector, which is like this. Now this may not be accurate, but it's good enough. Okay, so 3 kilometers, yes sir. And then the degree is always pointing towards the hypotenuse, which is here. So that's why we put 40 degrees. Um, then for the second vector, we would always put it on the last or the arrowhead of the last vector, which is here. So we're gonna start the second vector here. So west of north. So we start going to north. So we draw another line going up north, and then go to west. Boom. Then it's 4 kilometers 20 degrees. Okay, so we're basically drawing triangles first. And point here towards the hypotenuse and then do 20 degrees. And this is 4 kilometers. So what would our resultant vector be? We would obviously start with the first vector, the tail of the first vector, and end with the head of the first vector. So it would go up like this. So we don't know how to form the triangle yet, because we still need some missing values. So that's why we're gonna solve for the missing values, which is we're gonna find Rx and Ry. So how do we get Rx and Ry? First, we need to get Ax, which is the x of the first vector, and then Ay, which is the y of the first vector, and then By is the y of the first vector, or I mean the second vector, and then the bx is the x of the second vector. So now we have labeled it. All we need to do is solve it. So we are going to start with ax. So as you know, we already have 3 kilometers, which is the hypotenuse, and then 40 degrees. So all we need to do is find this, which is the adjacent. So how do we find that? You basically use the trigonometric functions. So katawa, cos for ax. So cos theta equals adjacent over hype. Or you can just do hype cos theta equals adjacent, where adjacent is going to be Rx. So hypotenuse 3 kilometers, cos cos, and then our degree is 40. So that's how we find x. So we just compute it, which is 2.30 kilometers east. Okay, we're gonna speed run this. So for the AY, it's basically the same as this, but instead of using cos, we're going to be using sine. So hype sine theta equals opposite, which is our x. So 3 kilometers sine 40 degrees equals x, which is 1.93, and north. It's north because this is going north. AY is going north. AY is going east. Alright, so now for the B. So BX, or we can start with BY. I don't know, it doesn't really matter. Let's start with BX first because it's easier. So once again, this is the opposite. So we're gonna use sine for that. Different from AX, by the way. So sine theta equals opposite over a hypotenuse. So hypotenuse is here 40, I mean 4, so 4 kilometers. Sine theta is like 20, so 20 equals x. So the x, or opposite, is 3.76 kilometers north. Wait, wrong one. 1.37 kilometers west, because it's going west. Now for BY, same thing but the opposite sign, which is cos. So 4 kilometers cos 20 degrees equals x. So x equals 3.76 kilometers north. Alright, now we have all the values. We are going to arrange it in a table so that it's easier to add them all. So A and B, these are the vectors, and then we have the respective I guess lines from them. So AX, like this, our AX is 2.30 kilometers east, and then our BX is 1.37 kilometers west, and then our AY is 1.93 kilometers north, and then our ABY is 3.76 kilometers north. So to find RX and RY, first we have to look at the direction. So north, Y has both north, so that means we just have to add them. So 1.93 plus 3.76 kilometers is 5.96 kilometers north, and then west, for X is, since they're on different directions, we have to look at the direction that has a bigger number, which is 2.30, and then minus it or subtract it by the other number. So 2.30 kilometers minus 1.37, 0.93 kilometers east. So that's our Rx and Ry. Let's get the resultant vector then, or the magnitude of the resultant vector. So R with an arrow. So you just use the Pythagorean theorem because this is just a triangle. We're trying to find the hypotenuse. So 0.93 kilometers squared plus 5.96 kilometers squared. That is basically equals to 5.77 kilometers. Yeah, kilometers. Alright, now that we know the resultant vector here, 5.77 kilometers, we don't know the angle where it's going, either here or either here. It's either east of north or north of east. So you can uh you can what do you call that? You can use both. But anyways, we're gonna find we're gonna draw a triangle like this, I guess. Oh, I'm pretty sure. No, wait, no. We're gonna use this. Okay, let me draw it. Boom, boom, boom. So this is 5.77 kilometers, and as we know, Rx is 0.93 kilometers east, and then Ry is 5.69 69 kilometers north. So going east or whatever, it doesn't matter which direction, as long as what you're trying to find is whatever. So either direction, since we made a triangle like this, we're gonna draw the angle towards the hypotenuse like this. So theta is equivalent to tan -1 over opposite over adjacent, right? So opposite is the opposite of the angle, which is 5.69. So 5.69 kilometers north over 0.93 kilometers east. The line here represents of, so that's why we're gonna go with north of east. So if you calculate that, that is 80.72 degrees north of east. So we combine this, the angle, and the magnitude. So the answer is 5.77 kilometers, 80.72 degrees north of east. Or you can convert 5.77 kilometers into miles, meters, which is basically 5,770 meters. 80.72 degrees north of east. Boom, easy.